Okay, so let me start. Before you can understand the concept of probability distribution, you have to understand what in statistics we mean by the word random variable. All right, what we mean by word random variable. And in order for me to explain random variable, let's begin with an example. All right, so suppose we toss a coin 3 times. We toss a coin 3 times. What are the possible outcomes? So it means what is the sample space? All right, so the sample space when you toss a coin 3 times, you get head, head, head. You could get all these 8 different outcomes that I am highlighting here. All right, so if you toss a coin 3 times, you're going to get 8 simple outcomes, right? There are 8 simple outcomes. Okay, so eight simple outcomes. Now, suppose we decide that we want to assign a numerical value to each outcome of the sample space. Now, for us to do that, we have to express our interest in measuring something about each outcome of the experiment, right? For example, we can decide that we are interested in the number of heads. Now, because I'm using the number of heads, you know that I'm going to count something, and things that are counted are discrete. The result turns out to be discrete. Okay, so here I could, for example, go back to the sample space. We can go back to the sample space. All right, and then I am counting the number of heads. So for each outcome, I'll count how many heads do I have. So for the first one, I have 3. The second one, I have 2. I have 2. I have 1 head. Then here I have what? 2 heads. I have 1 head. I have 1 head. And here I have no head. So what I have succeeded in doing here is that for each outcome I have assigned a number. In other words, I may decide that well, I don't need these numbers again. I don't need the values. I don't need these numbers. I don't need them. I don't need the simple outcomes again, because I now can use the numbers to represent each simple outcome. All right. So by assigning a number to each simple outcome, what we get is called a random variable. All right. So a random variable. What we get is a random variable. And usually we use the uppercase values to represent also a random variable. All right. Now the word random means chance, right? So a random variable, what is trying to do, you are assigning a number to each outcome of the experiment. But remember that because this experiment, each number we have here is based on chance, right? So each number is based on chance. So each value is based on chance, or each value of the experiment, each value of the variable is based on chance. Now, after I have gotten those numbers, I can decide to count how many of those. So now, in our case, x becomes what? 3, 2, 2, 1, 2, 1, 1, and then 0. I can decide then that I want to organize this into a form of a table, right? So I could create, let's say, a small table, let's say x, which is my random variable, and the distinct values I have here are the zeros, and then I can say how many zeros do I have. That's where frequency comes in. I have only 1 0. I can say how many ones do I have. I have 3 ones. How many twos do I have? I have 3 twos. And then how many threes do I have? I have only one three. Now, suppose you're in the lottery business, okay? Then do you see that if you want to run this as a business, you're going to give more price to the things that are harder to get. In other words, when you toss a coin three times, it's very difficult to get no heads, or it's very difficult to get all three heads. It's easy to get one head, and it's easy to get two heads because those things come often. But it's kind of little difficult if people want to bet on one head, no head, sorry, or people want to bet on three heads. All right. So just by giving more winning number to this, people will be attracted to it, and then they will stay more in your casino trying to get this, and you get their money, right? You could make a lot of money just from this small thing you have here. Okay, so now I can actually go ahead knowing that this is 8, right? The sum is 8. I can find the relative frequency, which is the same as probability, right? So the relative frequency of 0, it's 1 over 8, 1 out of 8. 1 is 3 out of 8. 2 is 3 out of 8. And then 3 is 1 out of 8. Now, when you sum this, the sum, it's equal to 1. Now, let me make it simple, all right? Let me make it simple by, what is coming on my screen here? Okay, let me make it simple by drawing just a table with just 2 lines, all right? So let me make it what I just did. Let me write it in the simple form. So this is x, and then this is a probability of x. No heads, it's 1 out of 8. One head is 3 out of 8. Two heads is 3 out of 8. Three heads is 1 out of 8. The total would always give here, its total probability is 1. So this table that I have here, this table that I have here, that shows the random variable and the corresponding probability that goes with the random variable. This table is what we call probability distribution table. All right, so this nice table I have here is called probability table. It's called probability distribution. So that is called probability distribution table. So in the probability distribution table, what you see is a random variable and its corresponding probabilities. You see the random variable and its corresponding probabilities. Now, specifically, this is a discrete probability distribution. All right, this is a discrete discrete probability distribution. Why? Because this random variable came out of counting something. All right, we were counting how many heads. All right, so this is a discrete probability distribution. Now, when you have a discrete probability distribution, or if you have a probability distribution table, two things must be true. So let me call that properties. Now, properties of something means what must be true of that thing. Number one, each probability should be between 0 and 1. So each p of x must be between 0 and 1. So I would say never negative. All right. Probability, each one of these numbers must be between 0 and 1. Each one of these numbers must be between 0 and 1. It should never be negative. The second thing that is very unique about probability distribution is that the sum of the probabilities, so the sum of all the probabilities, it's equal to 1. The sum of all the probabilities is equal to 1. Now, this is very, very important. Why? Because you could just have a question that is looking at, well, is it a probability distribution or not? Meaning that, do the table you are seeing, does it satisfy these two things? That each probability is between 0 and 1. There's no negative number in the probability side. And then when you add the probabilities, would you get 1? All right. So let me show you some example of how a question like this perhaps may look. Okay. Now, also, because probabilities, the sum of, because the sum of probabilities, so it says determine the probability distribution's missing number. Now, why are they saying determine the missing number? Because when you add the probability line, the answer, the sum must equal to what? 1. So you're going to ask yourself, what should I put here in the question mark that should give me an answer of 1? One way to look at it, or one way to do that problem, is to say that the question mark is equal to 1 minus the sum of what is there already, right? So this should be what? 12 over 17. 1 minus 12 over 17, or you could write 17 over 17 minus 12 over 17. So obviously here you get 5 over 8. That is so wonderful. So I want you to do this problem number 2. They said, what is this question mark? So this is a question mark. If you cannot see it clearly, this is a question mark. All right. So someone do question 2 and give me the result. Right, do is and give me the result. So the probability for the random variable 4 is missing, and then they are asking you to give us the result. So could someone do it and let me know? So you have, so the question mark will be 1 minus, what did you subtract before you got 0.47?
0.53.
Good. 1 minus 0.53, and that gives you 0.47. So some of your online assignment that will be given today will be like this. All right. So the answer is there. Okay. Now, other portions of your online assignment might give you probability distribution. Remember probability distribution, they give you the random variable and its associated, the values of the random variable and their respective probabilities. All right. Then the question will ask you, what is the mean? What is the standard deviation? Now, when you see questions like this, I want you to use, so when the question, when question asks for 1 mean, 2 standard deviation, and even 3 variance, I'll show you. Use the TI 83, TI 84. All right. Now, what would you be doing with your beautiful TI? This is what you're gonna be doing. Number 1, you're gonna start edit. All right. So if you have your calculators, you could work with me as we go along. So step 1, you're gonna start, then you go to edit. Now start edit, it's where you're gonna have like a table. the table will have L1, and then the table will have L2. All right. Under the L1, under the L1, put your X values. So put the 0, the 1, the 2, the 3, the 4 here. All right. Under L1, put your X values. Under L2, put your P of X values. So you are putting in your 0.30, your 0.40, your 0.20, your 0.06, your 0.04. Okay. Now, if this is probability distribution, like they told us, then your n should give you 1. When you add the probabilities, you should get 1. Probabilities, the sum of probabilities is always equal to 1. Okay. Then your step 2, you're going to start, then you're going to calc, C-A-L-C. Then it will say you select one var stats. When you select one var stats, depending upon what calculator you have, if you have T84, it will say list. Under the list, put in L1 here. Usually L1 will be there already. Then it will say frig list. Under frig list, put in L2. Then you ask for calculate. All right. Now, after you calculate, the mean is X bar. The standard deviation will be sigma X. If you ask you, the question asks you for variance, the variance is always the square of the, variance is always the square of the standard deviation. So plug in those values. All right, plug in those values and let me know the result.
While they're doing that, can you just scroll back up to the first 2 questions real quick so I can look at something? Okay. 4, 7. Hold on. Okay, thank you.
Okay. So let me scroll. Give me a minute. Let me push some things on the side. I know you can see the secret thing I am doing here, but I wanted to show my screen. Okay. So, all right. So someone already got the answer. Let me see if I can also get the same answer you got. All right, so let me power on my calculator. Maybe second quit. So you go to start, you go to edit, and then press enter. I've already preloaded the data there. All right. Then after you load the data, you go to start. Then you go to calc, one var start, select. Usually you would see this one here. Most cases the trig list may not be there, so you're going to do second. Then you type 2 will bring L2. Then you do calculate. All right. So when you calculate, so the x bar happens to be 1.14, and then the standard deviation happens to be 1.039, and then when you round it, you're going to get 1.04. All right. Now note that they have the n equals 1. You see that n is 1 to confirm that the sum of the probabilities is 1. If the n is not 1, then it's not going to, then you did something wrong in your data entry. Okay, so take note of that. Now, suppose this same question, instead of asking us for standard deviation, it asks us for variance. Now, if they are asking for variance, then we're going to take the standard deviation, which is 1.04, and then we're going to square it. All right, so someone square that and give me the answer. Okay, who's helping? All right, so 1.0816. Okay, so sometimes the question may ask you for standard deviation, sometimes may ask you for variance. So the calculator will not give you variance directly, but you know that the variance is the standard deviation squared. So you square the standard deviation, you square whatever standard deviation the calculator will give you, and then that will be your answer. Now, also, when you are given probability distribution, they can, another question could be that, oh, by the way, um let me show you here. You could be given something like this, and then they say which one, so which tables give the valid probability distribution. So when they say which table give the valid probability distribution, they're asking you which one satisfies the two properties of a probability distribution. Every probability should be between 0 and 1. I'm looking at this and I see that, oh, my friend here, you are not probability because that probability is negative. Number two, the total for the probability must always equal to 1, right? When you add the line, it must give you 1. Now, when I add the first line, does it give me 1? That's 5, 6, 7, 8, 9, 10. So that gives me 1. So this, like, okay. Now, when I add this, I get 1.1. So this is no good. When I add this, I get 1. So this is good. So then we would choose that. All right. Now, sometimes the question might be they may give you the answer within a multiple choice already done. So I look at this. Well, I see this is no good, so B is no good. Probability can never be negative. Then I check. Oh, this is
May I may I ask a question?
yes. Go
Can
ahead,
the
please.
value of x be -1? That doesn't really.
Because the probability distribution concept, the properties are only for the probability line, not for the x line. The
Okay.
properties are only for the probability side.
All right. So in what situation would x be -1?
It may depend upon what, let's say, if you are looking at, let's say, winnings and losses or kind of thing. All right. So let's say I have a business and the chance of you losing some money, it's let's say zero point 0.5, and the chance of you winning some money, it's let's say, chance of you losing money. Let's say I have like a business model where the X is maybe a win or a loss. So you bet, let's say $30, and your chances of winning your bet, the chances of winning your bet will be let's say um, point, or the chance of losing because zero point 0.4, or you could even have a positive, let's say zero point 0.5, zero point 0.6
Oh,
here
okay.
or
Okay.
something like that.
I get it.
So this may be a loss and this may be a win. Maybe let me make this a big number. Let's say $100. You win $100. So your chance of winning is zero point 0.6, but your chance of losing maybe is zero point 0.4, something like that. Um, so you can have X can be negative. So the probability distribution, the properties are only on the probability line, not on the X line. So in this case, this is 1.1 looks like. Um, Obviously, I look at D, and D looks okay because this will be 5 over 5, which is 1. So obviously C is not okay, and A is not okay. All right, so probability distributions can come in these kind of questions too, trying to see if you can apply the properties of probabilities, which is only applied to the probability side of the things. Now, you could also, apart from the question asking you to find the mean standard deviation or determine the missing value, the question may also ask you, in other words, you could be given a probability distribution, and then they could ask you to find probability. All right, they could ask you to find probability. Find probability. All right. Now, if they ask you to find probability, you're going to do the problem like a relative frequency. So here they said between 1 and 3, right? So between 1 and 3. So we are looking here, this between 1 and 3. Well, the total here, they said there's 1,000 households, so the total is 1,000. So a situation like this, what you could do, 428 over 1000 plus 256 over 1000 plus 108 over 1000. All right. Then you add the top because the denominator is the same. That's 1000. So when you add the top, that will give you what? 792, which gives you 0.792, which is this number. D. All right. So you can be given a table, and then they can ask you to find probability. It's the same concept, right? The most usual type of table you will see will be, let me show you this table, will be something like this. You are given a probability distribution because when you add this line, there's no negative. When you add this line, it should give you a sum of 1, right? And then they said find probability of x greater than or equal to 3. It means that pull from 3, 3, 4, 5. That's what it means. All right, so that is x greater than or equal to 3. So what we're going to do then is add the probabilities. The P here means probabilities, right? So we're going to add 0.37 plus 0.05 plus 0.14. Could someone add this for us and let me know the result? So 0.56. Okay, good. Now, let me also say this in passing, that Px greater than equal to 3 is not the same as Px greater than 3. Now here, 3 is not included. So x greater than 3 means what? Means 4 in this case, and then what? 5. So 4 has a probability of 0.05, and 5 has a probability of 0.14. So P of x greater than 3 would just be 0.05 plus 0.14, and then that gives us what? 0.1. 9. So this has been placed here. You see B is 0.19. It's placed there to confuse you if you don't know that the equal sign is included. So 3 itself is part of the solution. All right, so take note of that. Okay, so these questions Mostly would ask you for a missing value, like something is missing, and then they say, well, what is missing? I think we did some problem. Where is it? Something is missing, like question one and question two. It could ask you for probability, find a mean standard deviation, which you have to use your TI. Um, question four, question five, or it could ask you for probability. Question five, question six, probability of something. Like here, it says something less than two cars, right? So less than two cars, less than two. So two is excluded, less than two. So you're only looking for zero and one, this. And that's what you're going to work on in less than two. Now this says find variance. So you got to find sigma x. When you finish, then you square it, the answer. Okay. So your online homeworks may look like this. In addition, all right, you also may have for probability, you're given a table, and then this one, for example, says at least 25. Yes, you could ask your question, please.
Sorry, referring back to what you said earlier about the variance. Do they want the sample variance or the population variance?
Okay, all probability distributions are population data.
Okay.
Okay, so usually when you put in, you see that the sample variance, nothing will show there. Like I don't know if I put this thing off, if I put it on. You see XX on the screen, there is nothing showing.
Oh, okay.
All right,
I see.
because all probability distributions are always population data. Yes, Clara, can you ask?
I also have a question on the calculator. I'm confused as like when you plug in the numbers, how do you get like the L2? Because for me, I couldn't plug in like the frequency thing when you go to stat and then calc and then go to one var. It says for the frequency list that it's nothing there, so when I hit calculate, it gave me n equals 5 when it was really 1.
Okay, let me show you then. Um, so you went to start, then you went to calc, right? And
Yeah.
then you one var starts, then it looks.
No, it didn't look like that. It didn't have L2 for me.
It did not. It didn't. Oh, did it have frig list though?
No, yeah, it didn't have that.
It did not have frig list.
No.
Okay, so two possibilities. One would be, but do you have a list or you don't have a list?
Yeah, I do. It says L1 for that, but it doesn't have anything for frequency list.
Okay, so you're gonna press second and you press two.
Okay.
Then you go to calc. Then it will come.
Okay. Yeah, that worked. Thank you.
Excellent, excellent. Okay. Now, so these are some of the questions. The last set of questions that comes to 2.1 is that they're going to ask you for you to identify certain problems as either. So let me go back to our PowerPoint. So in the power and they're gonna ask you questions that relates to whether something is discrete or something is continuous. Remember, discrete are things that deal with only countable process, and continuous measuring process. All right. So let me take you through some example here. So in this example, maybe Brianna, can you read number one?
Yes. The number of goals scored in a soccer game. Excuse
Good.
me.
So it says number of something, right? So could someone tell me what the answer may be? Number of something means you are counting, right? Discrete comes out of
Discrete.
counting process. So the answer is discrete. Very good. Justin, can you read question 3?
The age of the oldest student in the statistics
All right.
class.
Good. So the age of something, you don't count age, you measure age. So that will be continuous. All right. Let's go to question 2. Jack, can you read question 2 for me, please?
The temperature in degrees Fahrenheit on July 4th in Juneau, Alaska.
Okay, so temperature, you don't count temperature, you measure temperature. So that will be continuous, right? Okay. Let me see. Alex, can you read question 4 for us?
Yeah, the number of phone calls to the attendance office of a high school on a given school day.
Okay, so number of something, right? So we're gonna say discrete. All right. So maybe Kali, can you read question 5 for us?
The number of pills in a container of vitamins.
Okay, so what do you think, Kali, in this case?
Discrete.
Excellent. All right. And Megan, can you read question 6 for us?
The height of a player on a basketball team.
Okay, and what do you think?
Continuous.
Excellent. All right, so some of your homework problems may give you a scenario like this, and then we'll ask you to identify whether it's continuous or discrete kind of things. Okay, so this will wrap up section 4.1. Section 4.1 is about probability, actually, it's discrete, discrete probability distribution. All right. So one, it will have like a missing p of x and ask you what is missing. Two, it could ask you to verify the probability distribution. So it gives you like a table. We know that probability p of x must always be between what, 0 and 1. Um, what happened to my computer?